All right, so for my inquiry 2 question, I asked, do the geometric properties of a ball affect the distance can be kicked? There's a lot of research on projectile motion, which is a side of physics that I really enjoy outside of my math, but that's pretty much only on the optimum launch angle for different sports balls, such as the prolate spheroid, which we know is the American football, and a sphere, which is what soccer balls are shaped as. This question came to me just in my interest of both geometry and projectile motion in physics. Up on the screen now, there are the two different balls I used. Those are the actual balls. On the left is the prolate spheroid, which is characterized by the two axes on each end, and then as you go closer towards the middle of the ball, that's where it becomes wider, which is different from the sphere, which is the same circumference and radius all the way through. These balls were kicked using a model that I built out of pressure treated wood, and they are these two pictures you see in front of you now. On the right, we have what the front looks like, and on the left is the side. They were made, like I said, out of pressure treated wood. The leg, which on the front picture is the middle part, that is 0.22 meters long, and the model as a whole is only 0.23 meters tall and 0.25 meters wide. So this model was built and it was scaled down to simulate a human kick, but on a much smaller scale than what we see in our sports. There were a couple limitations with this model, one of which is, like I said, it's a scale, so there's not everything we can get out of a human leg. One thing it neglects is that there's no foot on the leg, so the leg is kind of kicking without a foot, which is something that humans, most of us have feet, and most players that are kicking the football or the soccer ball have feet. Another one is that the balls that were used were made out of foam, and those were sourced through Amazon.com. They are stress balls so they're very malleable and they're very squishy. But that means that they don't act like normal footballs and soccer balls in the fact that they don't have a lot of air pressure in them, and the foam is completely different than the pigskin and leather that's used in the soccer ball and the football. Now for a video of it, this is what I did for every kick. The kicks, each ball, there were 3 balls for the soccer ball, 3 balls for the football. They were randomly placed into groups and then randomly ordered in which way they would be kicked. They were kicked a total of 6 times each, and then once those kicks were completed, the average of each kick was taken. And for this video, unfortunately, I could not get the balls to stay put for me, but I was on a flat surface to make sure that there was no angles the ball was being kicked up or down into to affect how far it could travel. For my data, as I said previously, I kicked each ball 6 times, and they were randomly placed into groups. The graph that is on this one is the average distance that each ball was kicked, as well as the standard error bars for each kick. One thing that was apparent right away once each group was done being kicked is that the data for each ball was somewhat over the place. The averages were about the same. For the football, they averaged out to be about 0.61, 0.62 meters being a distance kicked, and the soccer ball averaged out to be about 0.69 meters for each kick. But where the difference lies in each of the data points is exactly that. The data points were very all over the place. There was not a lot of normal distribution between each of the different balls. From the football 1, football 2, football 3, each data point was very different. And that's shown in my graphs here, where the sphere does not have a normal distribution at all. The distribution's all over the place of how far it was kicked for each kick. The prolate spheroid has more of a normal distribution, but even it is still very skewed right, and the data points don't make that distribution curve that we like to see. For the data itself, the soccer ball on average was traveling further than the football or the prolate spheroid, and it was only by not even a tenth of a meter. But like I said earlier, that's on the scale that I created, and I feel that to further research this topic, what we should do next is increase it to building a model that is the dimensions and size of a human leg that could kick balls that are the authentic sized footballs and soccer balls, and then we could really see where the difference lies, if there is any difference.